So these points, see how the distance is getting smaller in between them?
What is, it says 1.4. Isn't this one 1.4?
Oh, sorry, I was looking at question 3.
Oh.
So is the particle in figure Q1.3 speeding up, slowing down, or can you tell?
Slowing down.
Okay. Then 4, does that have a positive or negative value of acceleration?
Positive. Because it's still speeding up, and so, I mean, it's a negative velocity, but it's a positive acceleration.
What did we say about if it's speeding up? The signs are the same, right? Remember that? I just
Yeah.
talked about that.
But since it's getting faster, it's speeding up.
Mm-hmm.
That's not positive acceleration?
It's getting faster, you're right, but it's getting faster going this direction.
So what would be a negative acceleration?
So a negative acceleration is if it's going faster this way, right? So this would still be negative because it's pointed to the left. I know it's weird to think about, right? So you kind of have to reject what you're thinking. Like, so typically we think that if it's speeding up, it's a negative, or it's a positive acceleration. And if it's slowing down, it's a negative acceleration, right?
Yeah.
But with physics, it's actually based on our coordinate system. So if we say that positive x is towards this direction, we're moving towards negative x. So our velocity is negative, and we're speeding up, so our acceleration is also negative.
Okay.
Okay? And the best way I can kind of explain that is when you throw something up into the air, what direction does gravity point?
Yeah.
Right, so this is the acceleration due to gravity. It's negative 9.8 meters per second squared. So if you throw something into the air, it starts here, it's got a pretty fast velocity, and then it slows down, it slows down, it slows down, and finally it stops, right? So this whole time it has a negative acceleration, and it's slowing down, right?
I thought we just said that just because it's slowing down doesn't mean it's a negative acceleration necessarily.
The reason it's slowing down is because acceleration has a negative sign and velocity has a positive sign, right? So the signs are opposite, so that's what's making it slow down. So if it's speeding up, then they'll have the same sign. If it's slowing down, then they'll have different signs.
Okay.
Because now what happens once it reaches the top, imagine that this is the top, then what starts to happen?
What?
So you've thrown a ball up in the air, it reaches its highest point. Once it reaches that point, does it just stay there? Or does it keep going, or what happens?
It stops?
And then it turns around,
Yeah.
and it starts falling down towards you. And it speeds up as it falls, right?
Yeah.
So now it still has that same acceleration, negative 9.8. So acceleration is still negative. And velocity, what's the sign on velocity now?
It's speeding up since it's positive or negative.
Mm-hmm. So it's still negative. So now you have a negative acceleration that's causing it to speed up, right?
Yeah.
So don't get hung up on the sign of acceleration so much as whether it matches your velocity. Okay? Alright, I think that we've pretty much got that. Let's go on to chapter 2. Look at the summary. Okay. So this is kinematics in one dimension. And there's a couple of things. The basic premise of this whole chapter has to do with the relationship. You've got three things that you're looking at, right? Position, velocity, and acceleration. So, how are these related to one another?
They all have to do with physics.
Yeah, there's that. So if you look here, do you understand what this is telling you?
And motion, yeah.
So it's mathematically, so V of S equals ds dt. Have you taken calculus?
Yeah.
So what does this right here mean?
Derivative.
Yeah. So this is saying the velocity is the derivative of position. And this is one of the most important things that you need to know to continue on in this class. So velocity is the derivative of accelerate or of position. And then it says something about the acceleration, right?
Mm-hmm.
It says acceleration is equal to dv dt.
Oh yeah, we touched on this a little bit in calculus.
Yeah. So velocity is the derivative of position. Position or acceleration is the derivative of velocity. So I'm going to write that. There's a relationship here that's given by taking a derivative. Okay? So if you have an equation for the position and you want to find the velocity, what do?
You want to find
So
velocity? What?
say you have an equation for position that's S equals 4t squared plus 9. And you want to find out how fast that particle would be moving.
The velocity.
So you want to find velocity.
So you're gonna have to take the derivative.
Perfect. In this case, what would the derivative of this be, do you know?
8t.
Okay. So now you have velocity. What if you want to find acceleration?
Then you're gonna have to take the derivative again.
Perfect. That'll give you
8.
8. Okay. So this is the complete total idea. This is the proof. This is why all of this physics works. So the class that you're in is a calculus-based physics course. So this is the calculus that it's based on. Okay? So that's really good if you have an equation for velocity or for position. But what if...
So position is denoted with an S.
Yeah. That's kind of the generic S, but typically we end up using X or Y. So position can be S, X, or Y. Then velocity is V, V of X, or V of Y. Acceleration is A of X, or A of Y. Okay. So that's really helpful if we have an equation. Now you know if you're given an equation for velocity and you want to find acceleration, you take the derivative. But what if instead you're given a graph? Say you have a position graph, you start up here, and you kind of go like that. And there's a lot of practice problems like this. Let's say this is time, this is position. Let's call this 15 meters. 5 seconds. Negative, hang on. Negative 9 meters. 8 seconds. What if you're given this graph and it tells you to graph velocity?
You need to find your slope.
Okay? So what's the slope in this case?
Negative 24 over 8, so negative 3.
Okay? So your slope is negative 3. So how would you plot that on a velocity graph?
It would just be a straight line at negative 3.
Perfect. So here you've got, if you want to draw your velocity versus time graph, find negative 3, and you just draw it across. Okay? Now what if you wanted to find your acceleration graph from this velocity graph?
You have a slope of 0, so I guess it'll just be at that x-axis.
Perfect. Okay.